Hello, everyone. So today we are going to talk about number systems. Make sure that you put your name and your student number if you're in Miss Sissel's class, and the date if you are in Miss Armstrong's class. So first, we're going to talk about our vocabulary, and that's going to be natural numbers, whole numbers, integers, rational numbers, irrational numbers, and real numbers. First, we have natural numbers, and natural numbers are a set of numbers beginning with 1, 2, and 3 and go on forever. And what that means is if we made a number line, that number line would go on with all those numbers that you know, the ones that you count on your fingers and toes, kind of a thing. Then we have whole numbers, and whole numbers go on except that they start with 0 instead of 1. And they go on and on continuously through all infinity. Then those numbers are more like all of the numbers you can count on your fingers plus 0. Then we have integers. And integers are all the numbers that you can count on your fingers and toes plus 0 plus all the opposites. So 5 and negative 5. Or for instance, for a number line, you would do a number line and you would put 0 in the center. And then you would do 1, 2, 3, 4 all the way through infinity. But then you would do -1, -2, -3, -4 all through infinity in the other direction. Then, of course, we have rational numbers. Hold on just a sec. So just to help you with natural, whole, and integers, keep in mind, natural are the ones you can count on your fingers. Whole numbers include 0. And integers then also include all of the opposites. All right, rational numbers. Rational numbers, that's going to be all those numbers that make a fraction, or that you can say A divided by B. Now, B also cannot be a 0 because you cannot say 2 divided by 0 because that's 0. You can't have 2 pieces of 0. You can have 2 pieces of 5. So the fraction 2/5 works, whereas the fraction 2 zeros does not work. So that's going to include all of your fractions and decimals, positive and negative, okay? So then those numbers will also be found on your number line, but they tend to be sparsed between, such as 1/2 or 0.5. You can also have negative 0.5 and negative 1/2. You can have 3.5. You could have a negative 2 1/4. Those things will all show up on your number line, and so therefore they are all rational numbers. Now, the opposite of being rational is irrational, and so I know you just saw it blink up on my screen, but an irrational number then is things like pi, because pi doesn't end. Pi has, it's a decimal, 3.14, but it doesn't actually end at 4. It actually goes on and on and on. So it's actually 3.1415925, and it just keeps going. So that, just to give you an idea, pi keeps going. And even though there's a 7 at the bottom of the screen, that is still not the end. In fact, there are rooms of computers and mathematicians still working on trying to get to the end of pi, and they have still not gotten there. All right, so back to where we were. The next thing we need to talk about is real numbers. Also, irrational numbers do not repeat, ever. They do not repeat. That means if we have like 1/3 is 0.333 repeating. It just keeps going. But when you write down 1/3, it works as a fraction. And as a decimal, it repeats, so it remains rational, whereas pi is irrational because not only do the numbers keep going, but there's never been any point at which the numbers start repeating themselves. Next, let's see, we're talking about real numbers, and all real numbers are all those numbers we talked about that can be found on a number line. And if you have real numbers, then obviously you have imaginary numbers. And now that's not something you guys are going to have to deal with in the 6th grade. That's a little more high school level. So imaginary numbers, the one that we have right now is called I, and it's our first imaginary number. It is a what if question for mathematicians. What if this number existed that could blank? And so then they had to come up with this imaginary number. And currently, I is the imaginary number that represents the square root of -1. And we all know that you cannot multiply a number times another number to get a negative and it be the same number. Because if you did two positives, they're positive. If you do two negatives, they're still positive. So two numbers times each other don't equal a negative. So we've decided that there's this imaginary number out there that can do just that. And so it's called I. Like I said, though, you guys aren't going to have to worry about that till high school. So next we need to talk about our real numbers. And if you look at the bottom of your page, you see that we have to place these numbers on the diagram. So take a look at them and look and see what you see, and remember that real numbers are all the numbers on a number line. So when we skim through there, the first thing we see is that we have pi, and pi we already know is irrational, and it goes into the irrational spot. And then everybody else seems to be able to go on to the list where they are, except that now we have a square root of 25, and most of you know from looking at our board that 25 is one of those things that we've talked about with our dates on our boards. And you can see that 5 squared is 25. So then the square root of 25 would be 5, because the square root means one number times itself that equals this answer. And so we know that 5 times 5 is 25. And so 5 is definitely going to go on our list because it's still a real number. Then we talk about rational numbers, and those are those numbers that can be fractions and decimals and positives and negatives. And so that pretty much includes everybody again except for pi. And then integers, we start slimming that down. Now we don't have those fractions and decimals, so we get rid of those. And then whole numbers, as we narrow it down more, we start getting rid of the opposites, so no more negatives. And then we put those in here, and then natural numbers just exclude 0. So we have 2, 5, and 25, and 9. And that's about it, guys. So finish up your notes, take a minute. We can pause the video here in case you missed anything. You do not have to write down the number lines and all if you don't need to. They are a good example. And I will see you guys later. There's going to be a second video to show you how to do your guided practice on the back of the page. So turn it over and we'll get started.